So when we're in Grasshopper, this is our third time coming back to the board here on this one. There's one thing that we've kind of neglected is we have neglected the sort of magnitude of this vector. So we have, remember that a vector has a direction from first principles, has a direction and a scalar value that is going to set out the length of the vector itself. Now we unitized it and we ended up with a picture that looked something like this, where in the scale of the face we had said this is 1 point and a unit vector would maybe take us down to here. Now some of you might be saying the reason that if I drew the face, the reason that we ended up with the final point down here after our move was because we took this one and we moved him this distance L and he ended up outside of the face. So why wouldn't we just, instead of feeding this point into move, feed this point in? Because that would get us, we even saw it on the screen, roughly the right answer. And I guess the question there has to be is you have to start thinking, well, what could break that? Again, this had a distance of 1 unit because we unitized him, right? So it really is understanding that right now our input is actually, we've hardwired in there that not only do we have the input of this point A here, but also the 1 unit. Which means that the second that this face himself is on the order of magnitude that isn't, roughly speaking, maybe 2 units at this scale, that it won't work. So for instance, if 1 unit, if the scale is 0.5 units in diameter, then this script will not work. So it's very important to think this way, because if you don't think that way, this script won't work in many cases. It won't be robust. So how can we make this script work and be robust? So let's investigate that. So what's our input? Our input to this script is, we know we have the direction of our vector. That's no question. What do we want? We want the scalar, right? We're after the scalar. And actually, in the grand scheme of things, does the scalar have anything to do with the direction? No. The direction has nothing to do with the scalar. For us to get the numerical answer, what we're really looking for in this situation is something, relatively speaking, that says, what is this dimension relative to something else that we have, right? So right now we've determined this axis, let's say, but we have no idea about a length that should matter. Now, looking at the picture, let's just say, for instance, that we say, roughly speaking, that we know that, for instance, if we had it be a unitized vector, that it wasn't going to work. But maybe the scalar is the same distance. Maybe we move this point from here to here is, roughly speaking, okay if we say it's the same distance from here to here. We already have those 2 points, yes? So we could say that. That's option 1. Just say the distance AB is equal to the distance BC. So then everything would be relative to one another, and whether this thing was 10 units in diameter or 0.1 units in diameter, everything would be relative to one another. Could do that. Another option, and this is just the way you have to think, again, coming back to, you know, in order for this to work, we just need 2 points going in, right? Point A and point B, right? Equally, you could say that it's something else. So you could say I have the mouth. So option 2 could be I have the mouth. And at the end of the day, when it's all said and done, I want a scalar, same thing. But actually, if I draw the mouth here, and I draw what is to be my new mouth here, actually, I don't really care about anything else other than if this is X and this is X, that this ends up being x. That's the aspect ratio I'm after right here. And that's what matters to me most. And we could do this for many, many options, given what we have. But for right now, let's go investigate how these two options would pan out for our script and if they would work.